Hello, and thank you very much for giving us the opportunity to talk about organic UV filters. My name is Marcel Schnyder. I'm responsible for technical services, and we support our customers to develop nice sunscreens. I will switch off the camera then in order that you can see the full slide. First, I would like to give a short overview about the global requirements for sun protection. First, global norms and standard for SPF. So for a claimed SPF, the requirements that have to be fulfilled are in most of the markets done with an in vivo SPF measurement. In most of the markets, the ISO 24444 is used. In the US, there is a slightly adapted in vivo SPF method. But in general, SPF claims are substantiated with in vivo measurement with an in vivo method. There are some countries in Asia who do not require an in vivo measurement. There is a difference in the numbers that can be given, while in Asia, the in vivo measured SPF can be printed on the label. In the other markets, we have restrictions. Only certain numbers are possible to be put on the label as a claim. One exception we have with Mercosur. In Latin America, it's possible to claim SPF up to SPF 99, where in the other markets, SPF 50 plus, 60 plus in the US is the maximum claimed SPF. As mentioned, there is a harmonized situation in regard of the SPF claim. However, there is fluctuation in the results from test institute to test institute. Here an example where we tested several market products from the US market. This study was done in 2015, already quite some time ago. At that time, these products all claimed an SPF 50 or higher, and we sent the formulations to a European institute where the SPF was measured with the ISO method, and as you can see, the result was significantly lower than the claimed SPF, which is based on a FDA SPF most probably. So as a general statement, we can say there is fluctuation in the SPF in vivo method, and in tendency, European results are usually lower than compared to the US results. When it comes to the UVA protection, the requirements were set later. So in Europe, we have since 2007, we have a requirement that the UVA-PF has to be 1/3 of the SPF. So for an SPF 30, you have to have a UVA-PF of 10. There are different methods that can be used. So on one hand, also the ISO in vitro method, and we have also the ISO in vivo method. In Europe, Australia, the in vitro method is used, while in Asia, the focus is more on the in vivo SPF, on the in vivo UVA-PF method. The requirements are quite well harmonized, so even the labeling is different. The ratio SPF UVA-PF is more or less the same throughout the world. Some of the markets like Latin America, they adapted the European requirements. In the US, once the tentative final monograph is in place, it will also be in a similar ratio than what we have in Europe. Currently, the requirements are weak in the US. It's just a critical wavelength of 370 nanometer that is required. But in future, there will be more harmonization, also on the UVA-PF side. There are constraints on some of the UV filters, and the constraints are also different in different markets. Here, first situation in Europe. So here you can see E11 measurements. E11 means extinction of a 1% solution or dispersion through a path length of 1 centimeter. This is a measurement where you can compare the strength of the UV filter on the same base. So as higher the absorbance curves here, as better the performance of the different UV filters. You have here the UVB filters, here the UVA filters, and of course there are also broad spectrum filters available which absorb in the UVB as well as in the UVA area. In Europe, the European Chemical Agency has a so-called CORAP list where also UV filters are listed. The CORAP list is a list of substances which need more data. So where the European Chemical Agency sees a lack of data, and the filters which are marked in red are listed on this list, and some new data has to be generated in order to convince the authorities that the products are safe to be used. Even when all the UV filters which are listed on the CORAP list would disappear from the market, which is not really likely. So, but even in case the worst case situation would apply, we would still have enough different UV filters in the market in order to get high performance sunscreens with a high performance in SPF as well as in the UVA-PF. We can see here from the market reaction, this is data from Mintel. This graph contains products, new launched products, which are free from octocrylene and free from ethyl-hexylmethoxycinnamate, two UV filters which are under the radar screen of the authorities and which will be evaluated in regard of the environmental safety. And you can see that in 21, already more than 50% of the new launch products were formulated free of those two UV filters. Most of them or many of them have also some dedicated environmental claims. This is the orange line. So let's say around 70% of the new launched products which are free from OMC or ethyl-hexylmethoxycinnamate and free of octocrylene have a claim which inform the customer or the consumer that this product is formulated environmentally friendlier. Now to the situation in the US. Here are the also E11 measurements of the US-FDA approved filters. You can see the number of UV filters approved there is significantly less. Since the 90s of last century, no new UV filter has been approved by FDA. So there is already a limited choice to make high efficient sunscreens in the US. FDA required now for all the organic filters, which are in red here on this slide, some new data has to be generated. They asked for must studies, which are called maximal use trial studies, in order to check the potential penetration through the skin. So this new requirement from FDA does also apply for the old filters, for the filters which are already positive listed at FDA. The requirement is already used for topically applied pharmaceuticals, and in the US, sunscreens are registered as pharmaceuticals, OTC drugs. It is triggered by the lifelong and frequent use of sunscreen. And finally, the must studies look for UV filter concentration in the blood plasma after repeated dose. It includes all skin types, and it includes also different formats of formulations that have to be tested. It will be conducted under maximum use conditions, and this means maximum use conditions is 2 milligram per square centimeter application, 75% of the body area, 4 times application in a day during a period of 4 days. And then the level of the UV filter in the blood plasma is measured. FDA was performing a small-scale study. So FDA was asking for such data from the industry, but the industry did not commit to do such studies. So FDA did it by themselves, and they published it in 2020 and 2019, their own studies, what they did. What they found is will be discussed in the next slide. So they are requesting additional studies, safety tox assessment studies, in case they find more than 0.5 nanogram UV filter per milliliter blood plasma in their tests in these must studies. And here now the summary of the studies published by FDA. So already after one application, the level was exceeding the 0.5 nanogram per milliliter blood plasma. The concentrations were still above the threshold after 21 days after the study start. The concentration in the blood plasma found was independent, more or less independent from the formulation type. So they found it with all the different application forms. From the UV filter, oxybenzone showed the highest concentration of penetration, followed by homosalate. They have proven a good reproducibility of the study, and due to the data, the FDA requests additional toxicological studies. These studies will be animal tests, and they have to be provided, or they have to be done in order to prove the safety of these organic UV filters. FDA clearly also commented that the presence of UV filter in the blood plasma does not mean that the filters are toxic. For this, you have to do a risk assessment, and for this risk assessment, FDA is now asking for additional studies, as mentioned before. So when a customer would like to work with UV filters which are Grade 1, so generally recognized as safe and efficient, in the US, then the only options which are remaining in the US market are the work with titanium dioxide and zinc oxide. You can see here in black the absorbance of a typical zinc oxide and a typical titanium dioxide. So the choice is extremely limited, and it will be very difficult to achieve a high performance with just those two ingredients. What is the reaction of the industry, knowing that it is difficult to achieve high performance just with titanium dioxide and zinc oxide? It's also it has also sensorial disadvantages when a high load of inorganic particles is used in the formulations. So a potential solution could be the use of boosters to increase the performance of titanium dioxide and zinc oxide and achieve an acceptable sensory. Boosters can either be scattering particles, film formers, thickeners can help to increase the SPF of formulations. But there are also some non-registered UV filters or stabilizers which are used in the US. Examples of such ingredients are shown in this slide. So you can see here the octocrylene, so the chemical structure of octocrylene. This filter is under concern, so the FDA is asking for additional data. On the other hand, we have ethylhexylmethoxycrylene. It has a very similar structure. It is not registered as a UV filter, and therefore there is also no focus to ask for more data. So when we see the absorbance in red, we have the absorbance, the E11 of octocrylene, compared in light green here the absorbance of ethylhexylmethoxycrylene. So both have a UV filter function. The one in red is approved and under evaluation by the FDA. The light green one with a very similar structure is not approved as a UV filter. and is not under concern. The same applies also for ethylhexyl salicylate in yellow and butyloctyl salicylate, which is not a UV filter, not an approved UV filter, but has a similar absorbance than ethylhexyl salicylate, which is approved as a UV filter. When we look now for market products from this season, we can see very often it's claimed as mineral only or mineral sunscreens with very high SPF claimed SPFs. You can see here the active ingredients. Some of the players, they need 24% zinc oxide to achieve an SPF 50. We have others, they only need 12% for the same performance, or then combinations of zinc oxide and titanium dioxide of quite low concentrations are used to achieve an SPF 50. We can also see in red that all the formulations shown here, it's not all the formulations on the market, but quite often it's the case that these non-registered UV filters, what we have seen in the slide before, are used in quite significant concentrations. So it's now a question whether this was really the intention of FDA when they were asking for additional data to prove the safety of the organic UV filters. In Europe, actually, this is much less seen that such boosters or UV absorbing molecules are used, which are not registered. And the reason might most probably be that cosmetic directive is quite clear. So it is stated that UV filters other than those listed in Annex 6 and UV filters which are listed there but not used in accordance with the conditions laid down in the annex are not allowed. So this might be the reason why in Europe these molecules are not used to increase the performance, beside of the fact that in Europe the choice of UV filters is of course much wider. We have much more UV filters to be used. Now the problem found by FDA was the penetration, which was proven by these MUST studies. Now the question is, what is influencing a skin penetration? There are different factors, a large number of different factors, but the most important factors are marked in orange. So it's the lipophilicity of a test substance, the molecular weight of the test substance, the charge of the test substance, and finally the concentration used. So according to the publication here, best possible practice for low skin penetration are the molecular size. So use molecular size with more than 500 Dalton. Then it's very difficult to penetrate such molecules through the skin. The log POW below 1 or above 4, so very polar or very unpolar molecules do not really easily penetrate. A low number of functional groups or no functional groups in the molecules, so there is no interaction with the skin. And substances with a melting point above 50 degrees Celsius also tend to have a low penetration or no penetration. So actually, we do not know how the newer molecules, the larger molecules here would behave under MUST conditions because this data is not available. But what we can say from the data available from the European registration dossier is that a dermal penetration is less likely for the new UV filters with a larger molecular weight than for the older filters which have been tested by FDA. Now a short comparison of inorganic and organic UV filters. It is very often stated that inorganic UV filters act via scattering reflection. So they reflect the light, they do not absorb the light. This is also can also be found on labels of such sunscreens. In fact, it is not true. So also inorganic filters mainly work via absorption. There is no difference between inorganic particles and organic particles when it comes to the how they work, how they absorb the light. So it's mainly absorption. 85% is absorption. Only around 15% is reflection. So the main function of inorganic and organic particles is identical, is absorption. This is also shown or summarized nicely in this publication. When it comes to performance, there is a difference. So here again, E11 measurements and the comparison of the organic particles in orange to the inorganic particles in gray. So on the left side, titanium dioxide, on the right side, zinc oxide, two different versions. You can see that the organic molecules are significantly higher in performance. They have been designed for high absorbance, and they work, let's say, 2 to 3 times more efficient than inorganic particles. Means also the amount needed for the same SPF can be reduced by 2 to 3 times. What is identical for inorganic and organic particles on the other side is the correlation between performance and particle size. As smaller the particle size, as higher the performance of a particle, as larger the particle size, as lower the performance. This is independent whether it is zinc oxide, titanium dioxide, or whether it is organic particles. However, in difference to the inorganic UV filters, the organic UV filters offer more flexibility. So even when we take worst case assumptions into account, what I mentioned before, in case all UV filters which are listed on the CORAP list would disappear, which is not likely, there would still be flexibility, enough flexibility to achieve a high performance in regard of SPF and UVA-PF while using organic particles, because you still have the option to have UV filters in the water phase, UV filters in the oil phase. You still can work with particles and with soluble UV filters. While in case you only work with the inorganic UV filters, you are much more limited. Now I would like to focus on the environmental aspects, which are recently under discussion. As you might know, in October this year, organic UV filters, the ones which are approved in the US, will be banned in Hawaii. So it will only be possible to have sunscreens in Hawaii which are based on titanium dioxide and zinc oxide only. This will be adopted by Palau, or is already adopted by Palau, and maybe also by other regions in the US. In Europe, we currently have 11 UV filters on the CORAP list with open requests which have to be answered and which are undergoing further evaluation. When it comes to the environmental effect of a chemical substance, independent whether it's a UV filter or another chemical substance, it is important that the holistic approach has to be taken into account. This means not only parameter has to be taken into account. So it's not only the aquatic toxicity which is important, it's also biodegradation or persistence of a molecule which is of importance. When a molecule is persistent, it will end up finally in the sediment or in the soil. So also terrestrial toxicity and sediment toxicity is of importance. Bioaccumulation, of course, when a molecule is bioaccumulative, it is harmful for the environment, as well as when it is an endocrine disruptor, or even when it is suspicious to be an endocrine disruptor. Due to all these discussions about the environmental safety of UV filters and sunscreens, we developed a tool which is called EcoSun, which exactly takes all the different parameters into account. So the data, each chemical which is exported to Europe or which is in the market in Europe needs a so-called REACH dossier. So all these data has to be submitted to the authorities and is also publicly available. So the data which is public available has been taken as database for our EcoSun tool. The EcoSun takes into account the SPF and UVA-PF value. This is important as the most important factor of a sun care formulation is still to protect people from excessive UV exposure. Then the UV filter type used in the formulation with all these data behind, and the quantity of UV filter used. When you can make a SPF 50 formulation with less UV filter, it's always beneficial for the environment. Here you can see the classification that was used to classify the UV filters in the different categories. So for all these parameters, data is available when a product is in the market. So for each UV filter was ranked or classified according to this individual ecotox profile. We gave the same level of concern to each of the parameters. So we did not say biodegradation is more important than aquatic toxicity. All of these parameters had the same classification. In case there was no data or there is no data available, this might be because the evaluation dossier that is needed depends on the tonnage band you sell in Europe. As bigger the product is, as more comprehensive the ecotoxicological dossier has to be. In case no data was available for one of the parameters, we took worst case assumptions into the calculation. The calculation behind the EcoSun is transparent. It is published. It's also patented. So there is a detailed publication available how we do this calculation. Here are some examples of SPF 50 formulation, different filter combinations. The first example is based on octocrylene. Octocrylene has an aquatic toxicity, a significant aquatic toxicity, and is therefore not possible to calculate environmentally friendly formulation with octocrylene. Depending on the UV filter combination, you can achieve this EcoSun requirement. When the formulation meets an EcoSun of 200 or more, then it complies with the rule of EcoSun. You can see all these formulations achieved an SPF of 50 or more. And you can also see that this is achieved with completely different amounts of UV filters. While this formulation needs a 27% UV filter for an SPF 50. Here we can achieve the same performance only with 13.5% because we use filters which are much more efficient. The EcoSun is also part of the BASF Sunscreen Simulator. The BASF Sunscreen Simulator is a tool which is available and freely accessible on the internet to calculate the SPF and UVA-PF, expected SPF, expected UVA-PF of a UV filter combination, and EcoSun is part of this calculation tool. So I'm already with the summary of my slides. As we have seen, the requirements for SPF and UVA-PF claims on the labels are quite well harmonized, at least after the US-FDA tentative final monograph from 2019 is finally implemented. So much more harmonized than as it was 10 or 20 years ago. UV filters need in most regions of the, or in most markets, they need a registration or they are listed on a positive list. This also means they undergo most detailed safety assessments of all cosmetic ingredients. The choice of UV filters is globally reduced due to questions of authorities, mainly in regard of the environmental, sometimes also in regard of the human safety. The lack of performance due to UV filters that are disappearing from the market are sometimes filled with very flexible interpretation of what boosters should be. So even all organic UV filters which are approved in the US showed penetration under the FDA must study conditions. It does not say, it does not mean that this will happen also with the newer UV filters which are in the market, as simply no data is available. So today we do not know how the new molecules would behave under such must conditions. The modern UV filters are designed for highest UV absorption and for the best safety profile. And we have seen they also outperform inorganic UV filters. We believe with our EcoSun tool, we offer a possibility to calculate the environmental impact of a UV filter combination. Finally, the reduced choice of UV filters that can be used will finally also negatively impact the protection of the end consumers, which finally result in another concern, because we know that excessive exposure to UV light is a risk in regard of skin cancer. Thank you very much for listening. In case of questions, my colleague Miriam Sohn will answer those questions. Actually, I'm on vacation and cannot be with you live in this session, but Miriam Sohn will answer all your questions. Thank you very much.